Hey everyone, I'm glad to be here at Test Automation Days. Sorry I couldn't be there in person, but being in virtual space is almost as good. I heard a lot of good things about this conference from my friends and really wished I could be there. But hey, that's life. That's coronavirus life. So we're going to talk about today about characterization tests. And I'll dive into this in a moment. And I'll show you what we do when we need them, why we need them, and what to do when we try to actually work with them. A bit about me. My name is Gil Zilberfeld, Testing Gil. I'm a consultant for testing and development, everything that makes both testers, developers, any agile person more professional. You can find more about me and my books at testingguild.com. You can find me on Twitter and contact me through this email you see here. So let's start why we're actually here. The fact is that while we're always more concerned and more focused about the new stuff, creating new code, new value, a lot of the stuff that we do and a lot of stuff that brings us money really sits on the legacy code that we already have. And that's a problem when we start coming into the fact that we want to add automated tests. The problem is that the legacy code we've accumulated, which is working, creates problems for us to write tests. I remember like a few years ago when I just started reading about characterization tests and the tools around it, is I came to a customer and he wanted to start writing automated tests. And he had an application, both Java and C#, and lots of APIs he wanted to test, and the code was tangled. And we tried writing tests from the outside, but it wasn't really working. And then we did what I always do, which is offer, okay, let's change a bit of the code for testability. And they looked at me kind of nervous, saying, well, this is working, we don't want to break anything. So the fact is that we actually want to cover everything with tests, but in order to get them, we need to basically refactor code that already works. Writing tests is a problem, and we call that testability issues. And we want to get around this, and the way to do this is refactor, but we want to do it safely. And that's the key point here. If not, we're going to gamble, which sometimes it's a very small bet, sometimes it's a very big bet. So our starting point is we're writing tests to something that works. But the problem is that that thing that works is not always documented. When we're writing, maybe an API is documented, we know what to expect, but pieces of code like integration tests or unit tests, those things may not be documented, and therefore some so complex that we don't even know what we're going to check. The only thing that we do know is that when we're operating the system or part of it, it works. So whatever comes out must be the right thing. And this is the main assumption when we're talking about characterization test. Because what is a characterization test? It's a test that describes the existing behavior of the implementation. Now, I'm going to start by saying the assumption is the code works. If you write a test of the behavior and the behavior is not correct, we're going to capture a bug in a test, which is not a very good thing to do. But the thing that we don't have is really something that we can write an assert for. So what we're going to do is very simple. This is what characterization tests do. They characterize the system. You run the test without an assert. You see what comes out, and you say, well, this is the one thing that should come out, and therefore I'll write an assert for that. And if we do it a lot of times and we cover a lot of code, then it's pretty safe to start refactoring the system. Now, what I'm going to show you to do, characterization tests basically are a type of tests. And one of the way to do those is using approval tests. Approval test is an open source framework. It started off, I think, in Excel. But if you go to GitHub today to go for approval tests, you'll see support for many languages, obviously Java, C#, JavaScript, C++, C, all kinds of porting of this very useful tool. And I'm going to show you how I do it in Java. The concept is the same with the different languages. The implementation is a bit different. So what is approval tests? It's an open source library. I think they tried to brand it as approval testing, but the name approval comes from we're going to see what comes out of the system, and then we're going to approve it. Now, what we do basically is say, this is okay, like Chuck Norris did with a thumbs up. We kind of create a test and it captures the output. We'll see how. It logs the behavior of the system like any test does. Basically, it's a test like any other test, like tests with asserts, but we'll get back to the end about the comparison between these two. What it does is basically create a golden standard, and we'll see what that means. And when we keep that standard, and every time we run the test, it compares the output to these golden standards automatically. And when it compares it, it works. If it's not, it doesn't. And then we can do start refactoring. We can start refactoring in very small steps, as long as we're not breaking anything. So obviously, what we need to do right now is a demo. And the demo is on a small application I write for my exercises, which I do in my courses. Basically, this is a calculator application with APIs. Basically, what you see is you press on keys, which is one API. And second is you get a display. And the calculator itself, it's really stupid, right? It just does the calculation. But the display calculations somehow a bit complex, because this is like an old calculator. So for example, if you press 1 and then plus, the display displays 1, not 1 plus, and so on. This is not really relevant for our presentation today, but just wanted to show you what we're working with. So, and the architecture is very, it's REST-based, REST API logic, and also goes to the database. Again, possible to do this thing, what I'm going to show you with the repositories as well, but the demo itself centers today on the logic. So let's do a demo. I'm going to go to Eclipse. And this is my calculator controller. It's a REST controller. You can see that it has an API with a post method called press. It gets a string parameter with the key I pressed. And it also has a get method called display, which returns whatever the display is. As you can see, it delegates everything for the calculator logic. This is a good case scenario, obviously, where the controller is very thin. Sometimes it's not. But as you can see from the calculator A is not complete, B is very complicated. And that's a cool exercise for refactoring, as you can see. The display just returns the display. mostly, but most of the logic is on the press key. So what does the test look like? So this is a test called check display test, which is a very bad name for a test, but basically it performs one press and then calls the get display. Okay, now I told you what to expect. If you press 1, you expect 1, but we're starting off with, we don't know what will happen, but we know that what will come out is what we want to say is true. So obviously, if I run this test without this line here, there's no assert, the test will pass. I will add this here. So approvals comes from the approval test library. It's in the POM. Let's open the POM file to see that. Current version, where is it? Here is 9.3. You can get it from Raven Central. So instead of assert, I'm writing approvals.verify and putting in what I got from the response. Now, let's run it on the tests. There are 2 tests here. We'll see the second in a minute. This is a Spring Boot test. This is why Spring is running in the background. As you can see, I'm using the mock MVC to doing perform. Standard Spring Boot test for controllers. And the check display here is, you can see that I got an error, failed approval. And I see approval received. If I look at it, I'll see that for every test, there are 2 files created, the approved and the received. The received is what I got from the system, which is 1. And the approved is empty. I'm going to copy what I got from the received file manually into the approved file and save it. And now if I run this, wait, the test will pass. So basically what happened is that the approval created 2 files, the received and the approved. It wrote in the received what it got from the system. We approved that. We approved the golden starter by saying, okay, this is what we expect to come out of the system. And we put it in the approved, and it ran it again. And as long as the received and approved files, which is the received is created every time, is the same we expected, the test passes. The concept is very simple, although you're probably looking at why do we need it for this kind of test. So now let's look at the other test, because it's a bit more complex. So remember that what we want is to cover a lot of the code. And what I did just cover a part of the pressing 1, right? But I can do a lot of things, and I created press sequences, like I want to see what happens here when I press this. And so I have a press for every key here, which calls press and display after that. And I'm using a log. This is a log that I inject here, test logger. And whenever I call append, I'm writing press plus the key, display and show. And if we look at the received from this test, this is a bit more complex and elaborate. Okay. So as long as we keep that, we can actually do that. You can see something that I missed when I prepared this. The logger itself, which is basically a bean that I'm injecting, and this is a Spring thing, but it also works with any dependency injection in any framework. The same logger can be injected into other layers of my tests. So I can inject the logger here and write stuff in there in my code, which will come out here. This is in the plus. This is what I ended in the log. So that means my log, or my output of the system, which comes out, does not only have to be what I see from the outside calling the API, but also from the inside. So I can cover a lot of code, a lot of cases by logging all kinds of stuff. And as long as the system outputs this, I can refactor safely. And this is very cool, right? You can do it in small steps, run it, and things work. When do things don't work? If we're already here, let's look at the received part. And again, I'm going to copy everything to the approved file because it's empty now. I'm going to save it. And now if I run this, the calculated tests, everything should work. Obviously. Now, if I go to the calculator and I remove the things that I added and run it again, it breaks because the files are different. We don't have the in the plus line in the received file. And this is the crux of the sort of problem with characterization, with approval test or characterization tests. I'm going to switch back to my files here. It serves us in the window of time when we expect things to work the same. The minute we break something, like we did right now, we need to think, have we broken the functionality, like a real test, or have we added something new? Now, what I did just remove the log, basically didn't change anything, but the test passed. So I can do one of two things. I can return the line of code, obviously the line of log, or I can say, well, this is my new approved file. If it's just logging, it doesn't really matter. But if I do refactoring of the code under these premises, and I sort of get ahead of myself and I add a feature and something will break, I don't know if what I added actually worked. So just relying on these tests, we need to understand that they're good for something which is basically a limited time refactoring. And we need to be in control and saying, okay, if something is different, well, this is the new golden standards. We need to make sure that the golden standards is correct. So the good thing to do about this is to do the refactoring and then add more tests, real tests. Now, basically, you can write these tests like I showed you with approvals.verify, and everything will be dandy, and you can put the approved files in your source control and run these tests in the CI, and everything will run like a regular test. The only difference is that when those fail, you'll get a bunch of text which is different than another test because just does an assert equals on both strings. So if things change, you probably want, if you've written it from the beginning, better, more specific asserts. So the right thing to do is over time to replace these approval tests with proper asserts that will tell you why things break, and not because everything or somebody added a white space there. You're actually using an assert to test what's really important for the specific behavior. So that brings us to the end of this presentation. Basically, this is a very good way to do refactoring. It's better than not having tests, obviously, because otherwise you just gamble on your behavior that it will remain the same. It's an easy way, specifically with approval test, to capture the behavior. Obviously, one test, two tests are not enough. You need to write more and more sequences and log more in order to capture the behavior of the system in different cases. But once you do, and like I showed you, using like a log or something like that to just capture more and more information, you say, well, this is for my part of the system, this is how it works. It's very safe to start refactoring it. So at the end, you'll have something that works as it has in the beginning. And now we can write better tests for it. And I think this is the way we wanted to be in the first place. Remember, tests everywhere. Hey everyone, if you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.